Hello and welcome to Maths Problem Solving. Today we're going to be doing a question from an Olympiad paper in 2018. So let's get started with it. Okay, so here's the question. In the square ABCD, the bisector of angle CAD meets side CD at point P. Okay, so the information which we have is that this equals x and so does this. I'll just zoom in a bit. Okay, and the bisector of angle ABD meets AC at Q. Okay, so angle ABD meets... okay, so again, we can label a bit more information on that this angle equals Y, and so does this angle. Okay, so what is the ratio of the area of triangle ACP to BQA? So what is the ratio of the area of the two shaded triangles? Okay, so I guess how we will progress with this question is working out what angles x and y are equal to. So we know that angle ACD, well first of all, okay, so angle ABD is a right angle. We know that because it's a square. And now we'll need to work out what angle DAC is. From that we can work out what x is equal to. So angle DAC, C bisects angle DAB, therefore angle DAC has to equal 45 degrees. So if we just label that onto, and 2x equals 45 degrees, therefore x must equal 22.5. So that's going to be helpful hopefully later on. And I guess a similar thing would apply for y, because angle ABD equals 45 degrees. And 2y equals 45 degrees, therefore y also equals 22.5. Okay, so now we have two angles. We'll need to draw upon a few more relationships between these triangles. Okay, so I'm not really sure where the next place to go is, but I guess another thing which we can work out is what this angle over here is equal to. So angle QAB, sorry, must equal 45 degrees because angle DAC equals 45, therefore angle BAC must equal 45. And angle QAB is the same as that angle. Therefore this equals 45 degrees. Okay, so now we have this angle. And I guess the respective angle in the other triangle is this one over here. So angle PCA must also equal 45 degrees. Okay, so this was the main part of the question, because now I think it's going to get a little bit easier. So if we just go back to our diagram back over here. So we know that this angle over here, which I just highlighted in yellow, equals this angle. And then we also know another angle similarity, which is this angle equals this angle. And now if two angles are the same in two triangles, the third angle has to be the same because angles in a triangle add up to 180 degrees. Therefore, this angle, the final one, must be equal to each other in both of the triangles which we have. So just highlighted it in pink over here. Okay, so and now we know that the two triangles are similar. So let's just write that up over here. So ACP must be similar to BQA. And then since this is an Olympiad and we do need to show our workings, we'll say by AAA. That's the similarity rule, sorry. because if three angles equal each other in a triangle, then the triangles are just going to be like, I guess, like scale factors of each other, if you want to think about it like that. So now that we've established that both triangles are similar, hopefully we can derive a link. Okay, so we know that side AB equals 1. And since these two triangles are similar, if you want to think about it like this, is they're similar if angle QBA aligns with angle PAC. So like if you just flip the triangle, therefore not the hypotenuse, sorry, the greatest length in triangle QAB is side AB, which equals to 1. And now the respective length in this triangle is going to be side CA, which is this side. And we can work out what angle CA is equal to. Okay, so because if we just draw a triangle over here, side length 1, side length 1, and we need to work out what this length is, it's the hypotenuse. So this is just triangle ACB, which we have in our square. So angle CA is, let that equal h. So we know by Pythagoras' theorem that h squared equals 1 squared plus 1 squared. Therefore h equals the square root of 2. It's plus minus the square root of 2, but we can ignore the negative 1 for now. Therefore, if side AC equals root 2, we now have a linking factor between these two. So we know that the side scale factor between these two is the ratio of 1 to root 2. So now what the question is asking for is what the ratio of the areas are, but we have an answer for the ratio of the sides, which is all we need. So now what we could do is we could work out the areas of both triangles. Excuse me, we could use like a cosine rule or maybe sine rule or some trigonometric function to work out what both of the areas of these triangles are. But there is a much easier way to do it. So because AB to AC, the ratio of these is 1 to root 2, the side length. So as I said before, therefore the scale factor of these two is in the ratio of 1 to root 2. So now, like, something which you've probably heard about is, let's take two squares, and then let's call this side x and this side 2x. So now these squares, the area of this is x squared, and the area of this is 4x squared. So the side length are in ratios of 2, but the area lengths are in ratio of 1 to 4. So it's the exact same with these triangles which we have over here, because if you think about it logically, a two-dimensional object is just a one-dimensional object in another dimension. So it's going to have the same scale factor. So if we just write this over here, therefore the area scale factor must be 1 squared to the square root of 2 of root 2, sorry, which just equals to 1 to 2 as the ratio between the two triangles. Therefore, that's our final answer. Okay, so the main learnings from this question are that when you have two triangles, like triangles are unique in a few ways. So triangles, you can obviously do trigonometry on them. They're the only like shape which you can do trigonometry on. So we could have tried to use the trigonometry, but since the question is revolving around angle bisectors and things, so it just felt right to use similarity. And then after we derived a few angles which were common with them, we were able to derive a scale factor. And also another thing which you should try and remember is that the side scale factor is like 1 to x, but then the respective area scale factor would be 1 to x squared, which is what we used for our final answer. So thank you for listening to my explanation of this question, and I hope you have a good day. Bye.